So I'm going to talk about managing and analyzing time series data using a platform called Warp10. A little bit of background on who I am. I'm Mathias Herberts. I'm the co-founder and CTO of Cityzen Data, the company actually building Warp10 and providing support on the Warp10 platform and the Warp10 tool suite. I'm a former banker. I used to work for 15 years in the banking sector doing data analysis. I also worked at Google on the Big Table service. I was senior site reliability engineer in Dublin. I'm currently Frenchman. Depending on the outcome of our presidential election, that might change in 2 weeks. We never know. And you can reach me on Twitter at Herberts. So time series. As you've seen this morning, there was even a panel that was dedicated to time series. Time series are hype. I've put a few logos of open source solutions to actually manage time series data. So last year at the same time, there were probably half of those. So there are lots of new solutions actually coming out that want to both manage the data and offer a way to actually get value out of those data in many different sectors. Some of them, most of them actually focus on a first use case, which is monitoring. Some of them tend to address different needs. I'll briefly list a few use cases at the end of my talk so you can see how diverse the actual time series landscape can be in terms of use cases. But today I'm going to focus on one solution, which is the one we actually built, which is called Warp10. So we've been working on Warp10 since 2013 with use cases in the IoT. So our first use case was not monitoring, except for monitoring our platform with our platform. So we actually had the monitoring use case as an internal use case, but the use case we were actually focused on were purely IoT. First consumer IoT, then industrial IoT use cases for our customers. So Warp10, the work on Warp10 was started 4 years ago, and we decided early last year, in January 2016, to actually open source Warp10. One of the reasons for that was that every single time we actually talked to a potential customer, the first question that was asked was, are you open source? And the first answer we gave was no, which is never good in a sales pitch, right? So we looked at all the landscapes to see if that would actually hurt our sales, and we decided that the answer was no, it would not hurt our sales. It would even actually boost them. So we jumped shark at the end of January last year and have not regretted it ever since. So Warp10 is a rich tool suite for managing and analyzing sensor data. We use sensor data sometimes, and we use time series some other times. It actually depends on the audience. But since our first use case was really sensor data, we tend to prefer the sensor data name. And you will see that it's way more than a monitoring solution. So it all starts with a data model. So you've heard some talks this morning about the converging data models of all time series solutions. We have our specific data model, which is called geotime series. So one of the first use cases we were focused on were devices that actually measure physiological parameters like heart rate on professional athletes. One of the things that you have is those people actually move on the field, or if they're on the bench, they're usually, they don't have a high heart rate, so it's not worth monitoring. But when they move, you want to know where the measurement was actually taken. So very early on in the design of Warp10, we thought that putting space and time at the same level as first-class citizens in the platform would be the best way to actually address the use cases we wanted to address. So we created that data model, which is called geotime series, which is basically the fusion of a time series and the location of the sensor where the measurement was taken. So if we look more closely, a geotime series is basically a set of data points well, you can't see it here, but you'll see it on the online presentation. Each data point will be a timestamp, an optional location. If you have it, you will put it here, but if you don't have it, you will fall back to a regular time series, and a value. A geotime series is uniquely identified by two things. What we call a class, which is basically the type of measurement we're actually taking, and a set of labels, which are key values, in which you can actually project semantics from your vertical into the data model. We have another set, so class and labels, you cannot change them after you've started recording data into a time series, because they uniquely identify that time series. So if you change a value of a label, it's another time series. We have another set of key values, which we call attributes, which you can actually change during the lifetime of the series. And we'll see later what that's used for. So the whole of the Warp 10 platform is built around that geotime series model. The platform can have different time units. By default, it's microseconds, but we have customers that require nanoseconds. We have customers in a high-frequency trading business, and they actually measure timestamps down to 3 nanoseconds precision. So you can actually configure the platform so it accepts from millisecond to nanoseconds. In terms of value that you can push into the series, we support 4 types, so 2 numeric types, booleans and strings. The thing that you have to know is that a geotime series is actually not typed. So you can decide to push data which are longs, and then sometimes along the way you can change that to strings, and you can change that to boolean afterwards, or you can mix and match depending on your needs. And there are some specific use cases where you actually need to change the type of value. In the strings, we have full support for Unicode, so that's both in the class and labels and in the values. So you can actually store anything that's representable as a string. So we have customers who actually put images as the values of time series. You can put exotic languages like French with its accents in the name of the series. For the geographic part, we store latitude and longitude with a precision of around 1 centimeter at the equator, and the elevation is considered to be expressed in millimeters in the platform. And as I've said already, the geo part of the data model is purely optional. You can fall back to regular time series if you don't have anything related to location. Okay, so architecture. When we started developing Warp 10, we had the grand vision. We wanted to build a platform that was as scalable as other platforms were, such as OpenTSDB, for example, and we decided to actually have a version, which is the distributed version, and I'll detail that later, based on HBase. But actually developing a system that relies on HBase is a pain when you're the developer, because when you want to run tests, you have to run an HBase cluster, and then it actually makes things a little harder. So we decided to have another version of our platform, which we call the standalone version, which uses LevelDB as the storage backend. That version can also use an in-memory data store. It's meant to actually be deployed on a single server or on a laptop. It's actually running on my Mac right here. And you can build several instances of the standalone version to make a high availability version by actually using a feature which is called data log, which allows you to push data from one instance to the other and actually build a sort of ring where you have multiple instances actually pushing data towards one another. The distributed version is, as I've said, based on HBase. We also use Kafka as an intermediate buffer, and we have different components which you can actually scale independently. So basically, the data actually comes into the ingress component. It's pushed into Kafka. The store component will read it off of Kafka and actually store the data in HBase. The directory component will read the metadata out of Kafka and actually store the metadata in HBase. Egress will allow you to do analytics, and we'll talk about that later. And Plasma will enable you to do some real-time streaming of data out of the platform. And runner is just periodic execution of analytics as done by egress. And we also have a third version, which is an embedded version. And we actually have right now in the wild some industrial equipments that embed the whole Warp 10 platform with devices that we actually rendered intelligent by enabling them to do analytics on their sensor data directly at the device level. So we've actually deployed Warp 10 into generators, power generators. We've deployed Warp 10 into heat pumps and devices like that. So it runs in a Raspberry Pi. It runs on an Olimex card. Anything ARM based, you can actually run the embedded version of Warp 10. And the embedded version of Warp 10 is everything simply scaled down in terms of how much data you can handle. So APIs. We have very few APIs. We have one API to actually update data. So as the talk this morning during the panel put forward, we are in a push model. So you push some text-based format to the platform, and it will actually update the series with the data you pushed. This is done through HTTP, but you can also do it through WebSocket, so you can actually have streaming updates. There is really no limit in the amount of data points you can push in each request. We've had examples where we did some bulk imports and actually loaded several billion data points in one run. And we have throttling mechanisms, so you can actually limit the number of series or the number of data points that people are pushing. So we actually operate Warp 10 as a hosted service as part of our business, and we actually throttle the people according to the quota that they buy on the hosted service. The second API we have is to actually retrieve the raw data. So you can retrieve the data for a time period, for a select set of series which you will select using regular expressions. And we can output the data in various formats. We can output it in the text format that you've seen earlier, but we can also output JSON if you want, and other more compact formats for special use cases that I'll detail after. There's also an endpoint to actually find series without retrieving the data, so you just want to identify the series. We have customers who actually store in a single instance more than 300 million series, so it kind of become an urgent need to be able to select and identify the series that you have in your corpus in an efficient way. The find endpoint is the companion endpoint for another one, which is called Meta, which will enable you to actually change the attributes associated with your time series. So as I've said, we have a set of key values which are called labels, which are part of the ID of the series. And we have another set of key values which are called attributes that you can actually vary during the lifetime of your series. So one of the use cases for that, for example, is to either locate sensors which do not move by putting a location information using a geohash, for example, in one of the labels, and then later retrieving the series matching a certain area by querying specific geohash or specific regular expression on the geohash. We also use in the monitoring use case the attributes for signaling transient situations. So I'll explain that a little bit more. When you detect something using a monitoring script, you can decide two things. Either your script will actually trigger the action, or you will just mark the series as being in a certain state, and you want another script to actually take care of the action. So that's what the attribute actually enables you to do. So you have the first script that detects that a certain set of servers are in a certain state, and you want to mark those servers as being in this state. And we do that by actually adding an attribute to those series. Then we have another script that actually only looks at the series which have that specific attribute. So whenever a series appears with that specific attribute because the server is in a certain state, then it will be picked up by the script and action will be taken. We also use the attributes to actually remove expired data in certain situations using the delete endpoint. So I don't know about the US, but in Europe, it's a legal requirement that you provide your customers with a way to actually delete their data. And you need to provide them with a way where they can actually select what data they delete, right? When we're talking about emails or videos, that's rather straightforward. When we're talking about tens of thousands of billions of data points coming from sensors, it's another problem. Because we've had a customer actually delete 2.5 trillion data points over the course of 1 week. So that's, if you think about it, it's roughly 8 million deletes per second for a week. That's how much deletes it is, right? But you have to provide that. So we have an endpoint where you can actually delete complete series, so that's rather easy, or you can delete data points in specific range. And in the distributed version, you can delete data which is older than a certain age, right? Think about it for a moment. If you have a hosted service and you want people to actually use your service with whatever data they have, you cannot decide that the deletion of the data will be based on the date of the data points. Because if you do that, people will not be able to work on historical data. If you say my data is good for a year, then in our sense, it means that the data I pushed on April 23rd has been deleted yesterday, right? The data I pushed on April 23rd last year has been deleted yesterday because my data actually stayed for a year on my cluster, even though that data might have been 10 years old. We don't look at that. We look at the real age of the data when it was pushed. So since you actually delete data using the same selection mechanism as fetching the data from the series, you can actually play with the labels to decide which series you need to erase. So you can actually set up a pretty advanced lifecycle management for your data by using the fetch endpoint to look at what recent data you have, or do you have data in a specific range, and then the meta endpoint to update the attributes, and then the delete endpoint to select the data to delete based on the attributes that you just modified. And then we have the most important endpoint, which is called exec, which is there to actually perform analytics on your data. So the Warp10 platform is able to manage the data by storing and keeping large historical time series data, but it also provides, and we'll see that in the next section, a full analytics environment where you can actually analyze and create value on your time series without writing code outside of the platform. So we push an analysis script on an HTTP endpoint, and we get a JSON object as a result. So we can actually embed the result of those analytics in any environment that supports HTTP and JSON, which is pretty much anything. We've done it in COBOL, so I think we can do it from anything. We also have streaming endpoints to actually push data and to consume data off of the platform. So using the Plasma and Mobius components. So you can either subscribe to raw data coming into the platform, or you can subscribe to analytics. So you say, I want to subscribe on a WebSocket to the moving average every 5 minutes computed every second, right? So you can do that and then cascade that to some dashboards which will become dynamic. We have security mechanisms. Because we support multi-tenancy on our hosted platform, security was a very important concern from the ground up. So we have tokens mechanism to actually control who can access the data. So the tokens will bear what data you can access, what time range. We can have some analytics which will be triggered whenever you actually request the data. So you can think that you access the raw data, but you will really get a modified data that was modified on the fly and not the raw data from your token. By using that token mechanism, you can actually mix data sets from different customers in the same script. If you have the credentials, you can do that. So you're not containerized in a database or anything. We also have mechanisms for protecting the privacy of our users. So we have encryption mechanisms for the time series IDs for the class and the labels. You can disable it, but by default it's enabled. And we also have another mechanism that you can set up so you can encrypt every single data point. Some customers are paranoid, so you need to provide that. The overhead is around 20% in terms of accessing the data, because you have to decrypt the data on the fly before actually getting in a situation where you can do anything with the data. And we have integrity checks between the various components in our distributed version, and we can also actually fingerprint time series. Okay, so now the most important part of our platform is the part concerning analytics. So we started off a long time ago, 4 years ago, by thinking that we could actually have a very simple analytics API where you would have one endpoint for computing averages, one endpoint for computing standard deviation, et cetera, et cetera. But then very early on, we realized that the actual analytics we wanted to do on those time series data were more complicated than that. And if we did not provide something in the platform, then you would have, and every single user of the platform would have to do it on their application side. And if you look at what you have to build on the application side, it's far away from your business problems. So you don't want to have to build an efficient STL implementation because you want to extract seasonality from your series, right? You want that off the shelf. You just want to be able to use it and use the result of that analysis. And that's how our way of actually doing analytics on time series came to be. So we created a language which is called the WarpScript, which is dedicated to manipulate time series data and geotime series data. WarpScript is greatly inspired by the HP48 calculator and the Adobe PostScript language, in that sense that it's a stack-based language, and you can actually benefit from many things that you can find in PostScript, which is, for example, the ability to redefine the language while you're actually running it. So you want to redefine the plus operation to actually be something else, you can do that, and all your scripts that you run will actually pick up that new definition of that operation and will perform something like that. So that language that we started in 2013 was, in our view, pretty complete at the end of 2013, but as the time actually passed, we added more and more functions, and you'll see today that it has become quite a beast. So the idea of using WarpScript is that the JSON object that you actually get back from an execution is an array of the various levels of the stack after your execution. So that means that in the same analytics script, in the same call that you do to the platform, you can perform lots of different things and get all those back as a single JSON object, right? And then you can import that into your application. But that also means that you can fetch the data once and perform 10 sorts of analytics on the data, and you will only get the performance hit of reaching the data once, right? So if actually getting the data is costly, then you can mitigate that problem by getting it once and then duplicating the data, the raw data on the stack, and performing different analytics on those data. We're a stack-based language, but for practicality, we also support variables. So you can actually store things in variables that are symbols, and then you can later reference those symbols in your scripts. We support code serialization, so basically you can take a string and execute it as code. And you can also take a stack, a complete stack, and actually make a string out of it, which means that we can actually serialize partial execution of the program and actually pass that to another application, for example, or you can store it for later retrieval. And we'll see that there are some use cases for that are pretty interesting. We think that WarpScript is actually Turing complete. So we have loops, we have conditionals, we have macros. I'll describe that later. We also have the support for what we call secure script execution. So you can build an analytic script encrypt it, or ask the platform to actually encrypt it, and distribute that in your end user application in an encrypted form. And when the encrypted script is actually pushed back to the platform knows how to decrypt it and to execute it. So you can safely put sensitive information into your script. You just have to encrypt your script before actually distributing it to your end users, and they will be able to use it without knowing what's inside. So WarpScript has 5 high-level frameworks, which are very common things that you do on time series or geotime series. The first one is called bucketize. So one of the, might not be the case in the monitoring use case, but when you're actually recording data from sensors with a microsecond precision, your timestamps are never regular. So most of, at least lots of analytics you want to do require that you have regular timestamps. So the bucketize framework is here, so you can actually realign the timestamps on regular intervals. So you will ask for the number of intervals you want, or for the size of the interval, and you will apply a function on your time series. The map frameworks will actually slide a window on your time series, maybe with advanced and late data points, and we'll apply a function on those windows. Reduce will take n series and compute a single one. So for example, you can very easily compute the average temperature in your data center's rack by having a label with the rack number, and then simply asking to reduce all time series giving temperature by rack. So that's very easy to do. That's the reduce framework which will do that. The filter framework will filter and select time series or geotime series based on various criteria. So those criteria can be on classes, on labels, but they could also be on values. So you could say, I want to select all the series whose standard deviation is above this threshold, right? And the last framework is a general purpose apply framework, which allows you to apply an n-ary function to a set of series. So you can take one series, multiply it by another, divide it by a third one, and then compare it to a threshold which is stored in another series. And that will give you a result, which is a Boolean series with true or false, depending on if the computed result is or not above the threshold. So on those high-level frameworks, we have a set of functions. So at the end of 2013, we had 50 functions, I think, in the WarpScript language. At the time, WarpScript was actually called Einstein. It was not called WarpScript yet. We actually called it WarpScript when we became open source for copyright reasons. Today, WarpScript has 800 functions. And I'm not going to go into the detail of every single of those 800 functions. So compared to other time series solutions that offer 10, maybe 20 functions, we offer 800. And those 800 functions actually all had a use case in our experience. So we have ones about statistical tests, we have signal processing, so we have Fourier transforms, we have wavelet transforms, we have seasonal decomposition, we have quaternion handling for IMUs, for example. And then we have pattern detection, pattern extraction, lots of things that you can use in many different use cases around time series, which are included off the shelf in the WarpScript language. So what does WarpScript actually look like? Well, it looks like a script with a bunch of statements. You can have comments, and it does some pretty complex things in a very compact form. So I'm sure you can understand with the comments what that actually takes care of. So for example, when you have a counter and your counter resets, you need to reset the counter. So there's a function that's called resets, which will do that. So basically, the way you read that is the fetch statement will talk to the storage backend and actually retrieve the raw data and push them onto the stack, right? And then after that, you will operate on those data that are on the stack. So false resets will remove the resets in the series that are on the stack, replacing them with a series that were adapted. Then the bucketize will operate on those same series. The reduce also, the fill next, fill previous will actually fill the blanks. And then lastly, we will compute a rate on the result. So this could be done on a single series, but it could also be done on a million series. We have customers who actually perform such analytics on 1 million time series at a time. So the fetch will actually get 1 million series and data from those million series, and the rest of the script will be exactly the same. 800 functions is a lot, but there are many different things that we didn't implement because they're too specific to a single use case, or they are specific needs for specific customers, specific users that actually need to access third-party systems, for example. So we have many different mechanisms that you can use from within the WarpScript language to actually extend past those 800 functions. The first mechanism we have is what we call macros. So you can define macros, which are basically chunks of code that you can deploy on the server side, on the Warp 10 platform side, and they can be later called by the actual WarpScript code that you push to the platform. So you can separate the concerns between people working on macros and people working on using those macros. They can also, so they're swappable if you put them on as files on the server side, but they can also be deployed in a jar file and later referenced from your WarpScript. We can also modify the actual language using what we call extensions. So an extension is basically redefining or adding functions to the WarpScript language. So for example, if you don't want to use Warp 10 as the storage backend, but you want to use something else, you can simply redefine the fetch framework, or the fetch endpoint, the fetch function, and tell it to actually access the data in your storage layer of choice. This means that the rest of your scripts will not have to change, only that specific function, right? You can also decide that for specific use cases, you don't want to have lots of different functions that are in the WarpScript language, and you can decide to actually remove those from the language. You can also add functions, so you can add new functions to the language. So you can modify the existing one, you can delete functions, or you can add new ones, and have, depending on the context, a specific set of functions that are available in the WarpScript language which are not when you're in another context. We have another function for extending WarpScript which enables you to call external programs. For example, we've interfaced with TensorFlow. So what we do is that usually when we do machine learning on time series, what we'll do is that we'll use WarpScript to actually extract the features from your raw data. Then we'll feed that to TensorFlow to build a model. And then later, at runtime, we actually apply the model by calling TensorFlow. It could be done with anything else, any program that you can call that can actually interpret its standard input, you can actually talk to from within WarpScript, right? So you can have, you could interact with a shell script, which could call a specific library that you have. Anything exotic can be actually integrated within WarpScript by using the call function that we have. So we've stored data, we've analyzed data. Of course, one of the other things that you want to do with time series data is to actually visualize the result of your analysis and your computation. Here again, we have several tools that we've built. We have a set of components which is called Quantum, which are web components which enable you to display graphs and maps, or display images. The philosophy behind those components is that between the start tag and the end tag, the only thing that will appear is WarpScript. So you can focus on your business problem and actually doing the analytics that your business problem requires. And there is a calling convention between the web component and the script, and a return convention between the platform and the component. So for example, the script will be called with the component actually passing the widths in pixels and the heights in pixel, which is expected. So you can actually tailor how many things, how many data points you're going to return in your WarpScript result. This actually enables people to build dashboards without a single line of real JavaScript. So it's just a matter of actually referencing the web components in the header of the HTML page, but they're not going to build anything using JavaScript. If those components do not fit your needs of visualization, then you can always use standard libraries and actually instruct your WarpScript code to produce the JSON that is expected by your library of choice. So if you want to use D3.js, then you can actually use that and simply format the return of your WarpScript code as the JSON that is expected by your D3 component. We also have embedded within WarpScript the processing language. So I don't know if you're familiar with the processing language. It's a language which is mainly used by artists to actually produce visual art, right? So you programmatically build images and sequences of images. We've actually built that into WarpScript. So if you look at the heat map on the right, so that's a heat map with 3 million of tuples, speed and altitude of aircrafts, right? So if you're into aviation, you can actually recognize the flight envelope of an aircraft. You can see that they're actually, there's a line when they're below 10,000 feet at 250 knots, because that's the top speed that aircraft are allowed to do. The interesting thing about that map, so that has 3 million data points, is that it's produced by the WarpScript on the left. So it's pretty compact. The WarpScript, which is blue, is actually the one that produces the image. So it relies on macros that are server-side, but not that much code in the macros. And the interesting thing is that retrieving the data and actually producing that image takes less than 20 seconds. So we're fetching 6 million data points and actually producing a heat map and coloring that heat map in less than 20 seconds. We tried to do it using heatmap.py. We stopped it after 6 hours because it couldn't produce the heat map, but we can do it on the fly. So that's really interesting because you can actually produce some custom visualization using the processing language. We also have plugins for third-party tools for visualizing data. So we have a plugin for Kibana, and we have a plugin for Grafana. There are lots of people actually using Warp 10 for monitoring purposes, so we have plugins for those monitoring-oriented tools. So basically, you can declare in the Grafana plugin, for example, you can declare Warp 10 as a data source, and you can express WarpScript directly into Grafana. Well, the interesting thing about time series is that it's not only ad hoc queries that you want to do. It's not only ad hoc analytics on maybe a few days or a few weeks of data. Sometimes you want to be able to do analytics on your entire data set. We worked with an aircraft manufacturer, and he told us, okay, well, you know what, you did great analyzing those 5,000 flights for one aircraft, but could you actually analyze all the flights from all our aircraft since we've been doing aircraft? And it's a totally different story. So if you look at how people say they would do time series analytics in batch today, they usually tell you, well, you know, I'll just throw Spark at that, and I'll use Spark to actually do my time series analytics. If people tell you that, usually they haven't tried. The simple question I ask them is, even though there are some libraries that can do it in an easier way, but how do you do a moving average easily in Spark? Well, the answer is you can't, because it's not easy. It's difficult. You have to do things that are far away from your business objective. You have to do some plumbing on top of Spark, right? So we didn't want to be in a position where we would have that fantastic language for analyzing time series in the ad hoc world, in the interactive mode, and then when you switch to batch mode, you're stuck with other tools around which you have to build lots of new tooling, right? So what we've done is that we integrated WarpScript into existing batch analytics engines. So we integrated WarpScript into Pig, Spark, and Flink for batch analysis. So basically, you can use any of the 800 functions and any of the capabilities of WarpScript in batch mode on top of Spark. So you can load data from Parquet file, for example, analyze them using WarpScript with everything you have in WarpScript, and then produce a result that you will store back as a Parquet file, and maybe other programs can actually use that down the road. So that's an example in Pig. So you can see it very well here, but basically we have a function which is called WarpScript run, which you can use to actually execute WarpScript on input data, which is handled by Pig. And the same thing is true for Spark and Flink. So for example, if you take very long time series, in the case of the aeronautics example I mentioned, you want to chunk your data by fixed amount. So how do you chunk a time series which is 20 years long in 1 week intervals easily? Well, it happens to be that in WarpScript there's a chunk function which does exactly that. So basically what you're going to do is you're going to have a data flow approach on your data, chunk your series, then merge the chunks from the same interval together. So you reconstruct a series for each 1 week interval and then work on those intervals. And then after that you'll get a result and you'll be able to pass that down to another analytics pipeline. So we've done the same thing with Spark. Basically when you build your DAG, you have what we call a WarpScript function, and we also have a WarpScript flat map function, which you can use to actually apply WarpScript on your DAG. This is very easily done because, as I've said, the code in WarpScript is actually serializable. So you can take the code and actually pass it from node to node. So that's a requirement when you want to actually build a function in Spark. You need to have a serializable function. So it's natively something that WarpScript actually provides. So we added batch analysis to our ad hoc analysis. We also wanted to do the same thing on streaming data. So there again, people will tell you, well, you can always use Spark streaming, or you can always use Flink, or you can use Storm to actually work on time series data, which is true if you're willing to actually build the missing tooling on top of those low-level tools. What we've done is the same way we've actually integrated WarpScript into Pig, Flink, and Spark. We integrated WarpScript into Spark, into Flink, Spark Streaming, and Storm for streaming analysis. And we pushed even further in the case of Storm, because you can define Storm topologies entirely in WarpScript. So you can have a simple text-based topology definition, and we have something which is called run topology. And when we run a topology on that type of WarpScript input, it will create the actual topology in Storm using specific bolt and spouts, and it will run that locally or on a cluster. And there again, the ability to actually have serialization of the code makes it a very, very flexible solution for analyzing time series on the fly. So use cases. As I've said, we're not focused on monitoring. So we have very, very diverse use case examples. Nevertheless, the first one is a monitoring use case. So we have a customer actually monitoring several 100,000 servers, which equates to several 100 million series and several tens of thousands of billions of data points. And they monitor everything on the server, on the network side, on the storage side, on the containers that are started, et cetera, et cetera. So that's one of the extreme use cases that we have in monitoring. And that works actually on an instance, which is if you take the HBase apart, it's only 12 machines. So it's only 12 Warp 10 machines handling 340 million time series right now, and several millions data points per second. Another use case we have is in the energy business. So we help a company actually analyze synchrophasor data. So if you think about smart grids, we have what we call PMUs, so phasor measurement units, and they actually measure different elements of the network every now and then. Every now and then being usually around 250 or 400 hertz, so that's 400 times per second. So you will get the phase, you will get the frequency, you will get the amplitude of the electrical voltage and current in the grid. And if you look at correlation between different measurement points, then you can actually identify anomalies. If your phase actually shifts, it means that your smart grid is under stress. And if it stresses too much, then it will be islanded. So several parts of your network will be separated. And all those events need to be actually detected very fast. Because if you don't, then you're actually cutting power to people. So that's an interesting use cases. So there again, the number of data points is in the hundreds of billions. Not that many series, but hundreds of billions. We also work with companies providing telecommunication networks for high-frequency traders. They're actually monitoring the latency of every single packet in the network using our solution. We're working with people who want to access forecast data, weather forecast data. And globally, the weather forecast provided by the NOAA is roughly 300 billion data points per day. And they want to have historical access to that data. So lots of interesting use cases. You have to understand that all of those use cases were actually handled using the exact same technology stack. So we don't have a version of our stack for the utility business and another one for aeronautics. It's the exact same tools that we're using in the various use cases. So, if you want to get started with Warp 10, it's very easy. My advice is to use the standalone version. So take those 3 lines and depending on how much time it actually takes to download it, but you will be up to speed in less than 10 minutes. So that should actually get you started. From there, you can actually push data, you can read data. And if you have questions, we're available. So the documentation is available on www.warp10.io. We're actually lagging a little bit behind. I think there are only 700 functions that are documented. So hopefully you don't need the 100 newer functions that are not yet documented. They will be, don't worry. We have a Google Groups, which you can actually use to ask questions. And we'd be very happy to actually know how you would like to use WarpScript or integrate WarpScript into existing systems or make bridges between WarpScript and any other system out there. Please rate my session if you have 2 minutes, and I'll gladly answer any questions you might have at that point.
When did you open source?
We open sourced it on January 29, 2016.
Do you have an alerting component?
Sorry?
Do you have an alerting component? You talked about an
alerting,
storing. Do you have an alerting?
We actually have a set of macros that build specific time series which are interpreted as alerts. So basically, when you detect a situation in your time series, what those macros do is that they will create and populate a specific time series which is the actual alert time series. And from that, you can actually trigger notification. It's a little bit like the way the alert manager in Prometheus actually works. And we think it's the right way of doing things because that gets you an historical view of when your alert's actually triggered. So they're really time series. And you can see when people actually acknowledge the alerts, et cetera, et cetera. So if you have very strict SLAs with your customers, then you can prove them by showing them the time series how the alert was actually handled.
I have a question that basically your backend, how many tags or columns is supported for each specific time series?
How many tags?
Yes.
Per time series?
Per time series.
It's actually not limited. It's usually limited by common sense, but we have customers actually putting more than 100 tags and lots of diverse values into the labels. No more questions? Oh, yes, there's one in the back. One last one, I think, is she showed me the 1 minute sign.
Yeah, the open source, version, is that also like a clustered version, or it is just a single server version?
The open source version covers both the single version, what we call the standalone version, and the cluster version. It's not limited. We didn't go the InfluxDB way. You can actually, we have users which are not customers using the clustered version of Warp 10 on top of HBase without them paying us anything. So that's not the way we make money. It's not by having enterprise features. We think that anybody should be able to use all the features. The thing is that when you have a language with 800 functions and people want to go fast, they usually talk to us. If they have the time to invest and they say, you know, we're going to save money, we're going to spend time, then they can go on their own. If they want to go fast, then they become our customers. Well, if you don't have any more questions, thank you very much. I have a bunch of stickers if you want.